Great. So I'm Torey Penrod-Cambra, Chief Communications Officer at HighByte, and I'm going to be your moderator for today's panel discussion. I'm excited to be here today with my colleagues, Aron, and hopefully Jeff soon. Yes.
You say his name, he appears.
Oh, miracle. For another office hours session, we're calling Industrial AI Deep Dive. And hopefully Jeff's internet continues to cooperate. That's always the exciting part of doing these live office hours. So let me introduce our panelists now that they're both here. Jeff's a product manager at HighByte, focused on product positioning, technology partnerships, and reference architectures. He's an experienced technologist who brings more than a decade in leadership roles in the automotive and discrete manufacturing industries to his role at HighByte. Aron's the CTO of HighByte, focused on guiding the company's technology and product strategy through R&D, technical evangelism, and supporting customer success. Aron has more than 15 years of experience in industrial technology, and you probably know him because he's become a bit of a YouTube celebrity. More on that later as we get into Aron's demos. So first, let me go into some housekeeping items. Cue this up. There we go. So yes, of course, we did get some questions about this. The webcast will be recorded and shared via email in the next 24 hours. Please use the Q&A tool. So chat's a great way to communicate with each other, but if you have a question for the panelists, please use the Q&A tool during the webcast. And our colleagues Ryan and Ty are online as well, and they're ready to answer your questions. So hopefully we'll also have some time at the end for live Q&A with Jeff and Aron. All right, so for the next 55 minutes, we're going to show you how to fully leverage AI on the factory floor with MCP and AI-assisted DataOps within HighByte Intelligence Hub. We'll also introduce you to other new capabilities in the latest release of HighByte Intelligence Hub, which is version 4.2, and bring that together with 3 product demos that bring this whole discussion to life. So a little bit about HighByte for those of you that are new to HighByte, which I actually noticed in the registration. There's a lot of new faces here, which is great. So at HighByte, we're on a mission to provide manufacturers with the data infrastructure and data context they need to get digital transformation projects out of pilot and in enterprise-wide production. With more than 400 global deployments, our proven industrial DataOps software, HighByte Intelligence Hub, is helping us accomplish that mission. Since founding the company in 2018, customers now span 24 countries and 20 vertical markets, including life sciences, automotive, pulp and paper, oil and gas, and many more. So what exactly is HighByte Intelligence Hub? We would describe it as a DataOps application that's built for industrial data and deployed at the edge. The Intelligence Hub delivers modeled, ready-to-use data from any asset or system to its target using a low-code interface to speed integration time and accelerate analytics. With the Intelligence Hub, you can merge telemetry, transactional files, time series data from a wide variety of sources into a single payload. You can standardize and contextualize information models in real time. And importantly, as we'll discuss today, you can prepare data for industrial AI use cases. So let's talk about our agenda today. In the next 55 minutes, we will review some fundamentals of MCP and MCP tools. You'll see how to build custom MCP tools for AI agents that interact with industrial systems, including MES, CMMS, operational data, and files. Aron has some pretty exciting demos planned for today. You also get tips for leveraging LLM-assisted data contextualization in the Intelligence Hub to rapidly identify assets and map instances. You'll learn how to apply DevOps best practices to industrial data management using OpenTelemetry and Git. And along the way, we'll show you some new connectivity options in the Intelligence Hub and save some time at the end for a sneak peek on the product roadmap. So without further ado, I'm going to jump in and ask the first question. So good level setting question, I think. A few of you had asked this, so went ahead and summarized it. What is MCP and what are MCP tools? And for this question, I'm going to start with Jeff.
Fantastic. All right, so let's first level set on
the problem that that MCP solves, or how we kind of found ourselves in this mess in the first place. So obviously everyone's enamored by generative AI and large language models, and that kind of starts with this kind of chatbot type scenario, right? And then next, someone wants to kind of operationalize this, right? They want to do more sophisticated things, right? Generative AI is effective for kind of creating things, right? But what if you want to do things, take action on things, or maybe interact with large language models in a more sophisticated, perhaps autonomous or semi-autonomous way? And yeah, you can make decent prompts and so forth, but this kind of presents some problems here, right? There's a context problem, and there's also a supervision problem. Just like as you've probably seen before, if you use any of the large language model services and you prompt it, you over prompt it, right? You start getting kind of undesirable results, if you will, right? And as you probably have noticed, right, you kind of have to trick it or have a good strategy with respect to prompting, right? And the problem is that those large language model services are kind of missing context, right? You either have to manually take those resources and effectively feed them in and kind of develop a prompting strategy, but really to operationalize this, you essentially have different data sources that are kind of locked up. So the approach that many people have begun to take, and this is kind of this whole agentic AI thing, right, is that it's adding an element of supervision. Instead of directly prompting the language model, maybe that's done to an agent that knows how to iterate through it and it connect to those services. This seems like a step of an improvement, if you will, but there's some additional problems here, right? When you think about those different services, right, you now have this integration problem, right? Different services, different documents, databases, different systems within your factory and your enterprise all speak different protocols and so forth. But even after you figure out the whole protocol issue, right, those resources are maybe not necessarily designed for a large language model to effectively reason upon them. So introduce MCP, right? MCP is essentially, it's a data contract between agents and different systems, right? It starts with an agent being able to reach in and kind of assess what are the capabilities that are available within an MCP server. And primarily it indicates, are there certain MCP constructs referred to as tools, resources, or prompts. The one that we want to really focus on today is tools, and Aron will do a lot of demos in that particular realm. But the real important thing here is to discover what those tools are, being able to reason upon those tools and issue requests upon them, and then take result sets. So essentially the agent is kind of doing this round robin pattern of monitoring what prompts are doing, going to a language model service, interacting with MCP servers and back and forth and so forth. But still, this is great, but there's still even another problem, right? The likelihood that you're going to find an MCP server directly on anything in your factory anytime soon is slim to none, right? And then even further, there's a larger problem of with kind of all the excitement, or dare I say hype, over AI. A lot of people are simply just wrapping MCP server interfaces over traditional API endpoints, if you will. So the problem with that is that there can be reasoning issues, right? There's not enough context provided there and so forth. So I guess a good definition of good might be having a dedicated, concerted data infrastructure that's designed to kind of expose systems as effective tools. Just giving a look back at that history from the past few releases of the Intelligence Hub. About 2 years ago, we released the REST data server. And this just shows you how fast the whole MCP or agentic AI space has heated up over the past 6 months or so. Late last year, Anthropic public released the whole MCP protocol. And then there's right at the start of the new year, we with the release of 4.1, we added the capability of taking the REST data server, which was essentially an API gateway, but giving users the ability to be able to build custom endpoints, or essentially building custom pipelines that can be evoked by external clients. As MCP has sort of taken off over the past few months, and most of the major platforms and players in the industry have began to adopt this, this approach of this kind of industrial API builder pattern, if you will, lends itself quite well to MCP. And so in this release, we essentially exposed our data plane with an MCP server interfaces such that AI agents can effectively interact with data pipelines. We see this as really, really critical because ultimately for AI agents to be effective, you need to be able to build well-balanced tools to interact with them. So that is tools that are providing enough context, not too much data and not too little, and they're being judicious with how compute and resources are utilized.
Great answer, Jeff. I feel like is interesting to see the timeline too, and to see how the Intelligence Hub is uniquely positioned to be able to act as an MCP server, given the data virtualization that we already had in place. So thank you. It's a good answer. Let me jump back in. I have another question, and this seems like very specific to a couple applications, but I think there's something interesting underlying in this question. So I'm going to come back to you on this, Jeff. And this question came in from Doug in the US. If I have two software systems like SolarWinds and ServiceNow, which I'm trying to connect to each other via API calls, is HighByte Intelligence Hub an appropriate middleware solution? Where does MCP fit into this scenario? How would you answer that question, Jeff, and help us understand the difference between MCP and APIs?
Great question. Yeah, I find this really interesting because this is a pure IT to IT node integration, and typically this is not like our core market. We do have plenty of customers that are integrating with ServiceNow, but I think it's appropriate to first level set on what are these solutions. SolarWinds is basically an IT management suite. It can be used for monitoring servers and managing networks and so forth. And ServiceNow is largely an IT service management tool. It's expanded a bit beyond that, but typically you might use that for alerts or basically planning the work of managing infrastructure and so forth. So I'm gonna just pull up a couple of diagrams here. Hopefully this is showing up. So first of all, what I'll say is this is a common pattern. And in fact, both these companies have a direct integration, right? So I would say the first thing is you probably don't need us in some cases, right? If you want SolarWinds to raise a ticket in ServiceNow, go ahead and maybe first of all explore looking at the native integration. I will say, well, we can integrate between IT nodes, and we're frequently blending industrial data and IT data, or taking industrial data and moving that into the IT realm. We can theoretically integrate between IT nodes, but the Intelligence Hub is basically purpose-built to solve the issues and challenges that you might encounter in the industrial domain. This kind of mediated approach might make sense to say maybe that direct integration that has been productized doesn't solve the outcome that a user desires. Maybe you don't want to simply just open a ticket. Maybe you want to do something more sophisticated. We have pipeline processing, and that is theoretically possible. So these are standard approaches with just normal APIs. So think of this as kind of large language model hysteria era that we're now in. But the final one scenario is agentic AI, and I think this is maybe what was kind of prompted on. Yes, theoretically, we could connect to both. We could expose SolarWinds and ServiceNow as an MCP server. An AI agent could interact with that. It could do reasoning on a large language model services such as Claude, hosted in Bedrock, as an example. But kind of the problem is that these integrations are going to be inherently stable. They're not going to drift a lot over time. And so the question is does it really benefit from reasoning? Do you really want to generate code on demand in this type of scenario? What I think a more appropriate approach might be, if you really wanted to absolutely use generative AI, is maybe supervising like Lambda functions or middleware for alerts after it. But I think this is a better case for maybe generative AI. So maybe I'm going to generate a script to do this integration between these two nodes. I'm going to validate it and then deploy it. I don't necessarily know that would benefit from continuous reasoning after it's deployed into production.
Good, thanks, Jeff. Okay, I'm going to launch into the next question, which also sets us up for the first demo to come from Aron. And thank you, first of all, for so many of you asked questions when you registered for this. A lot of them were around this bottom one, like, how do I do this? Like, show me how I build these custom tools. And the top question specifically came in from Deepak in the UAE. How can I use specs of an asset in MCP server to prompt the end user and trigger a notification to end users? Can you show an example? So I think what people really want to see is, how is this done? So for Aron, I'm going to turn this over to you to show us a demo. And I'm going to warn you that you're on mute.
There we go. I knew at the instant I started talking, but I was trying to share screen, so I was all lost in the prompts. Cool. So I'm going to answer the first question. I'm going to answer last, and then I'm going to focus more on like how to build MCP tooling around all the data that we can connect to. So how you expose that industrial data today to agents, and why building tools is actually really necessary as you go to optimize agents and agentic workflows and then flow that out to production. So before I start, we have a Git integration now. We'll get into that towards the end, but everything I'm about to do is up in this Git repo now under HighByte sample projects, which is public. You can go to webinar 2, and then in here, there's a config JSON file that is I tweaked it a little bit, but this is the configuration I'm running. So what you can do is take this, you can import it into the hub via our project import, and you can follow along after the webinar with everything that I've done, right? So, super useful. I'm going to move pretty fast like I usually do, but that's a way to go back and be able to look in depth at kind of what I've built out. So I'm not going to focus on enabling MCP. We have videos on that, or setting up MCP inspector, some of the tools I'm going to use. Where I'm going to start is in this sample project, I've built a classic UNS, which is MQTT based. And that's what you're looking at now. And it's simulating a fertilizer plant. And these are the machines that are in the plant in a line 1, and that data is running. And the problem I'm going to try to solve for you in this demo is we want to build MCP tools around this UNS such that we can use agentic AI to interact with it, and show you how that's done. So what I'm going to do first is I'm going to jump out to pipelines. And if you look at this project, in here I have like the data I'm simulating. It's all in JavaScript, so you can run this locally. I have the UNS workflow, which is pushing that data out to the UNS. And then what we're really going to focus on is the MCP tools that I've built. Now, I've built MCP tools for a bunch of different data types: Ignition, Pi, Timescale, MQTT. We're really just going to focus on MQTT and Pi for this example, but these demos are here so you can see how I'll say MCP enabled Ignition data in this project. But specifically, we're talking classic UNS. So what I want to expose first, just to get started, is a tool to be able to browse the UNS. Browsing is not a native MQTT capability, so we need to augment that. It's not in the technology. And then the ability to read a certain topic. So let's look at browse first. And what you'll see in here is we have an API trigger that's the start of the pipeline. And what this is saying is expose this pipeline as an MCP tool and over our REST data server. So this is how you inform us that this needs to be exposed externally to agents. So that's turned on. And rather than walk through exactly what this tool is doing, I'm just going to run debug mode so you can see what it does. So when I run this, it's going to go through, it's going to read the MQTT namespace. It's going to do a little transformation to pull off the topic paths that are in here. And then this is verbatim what it's going to return to the caller, in this case, an MCP client or the agent. These are the paths or the topics that it can read. So this is the data that's in our UNS today. The other one, which I'll show, is the read. And what this is doing is same thing. It's got an API trigger. It's actually passing a parameter that's a topic. So the agent's going to say, I want data for this topic, which is just a string parameter. That topic gets passed, and I'll just show this real quick because this is our new param passing feature. It gets passed to an MQTT input and just substituted in for the topic. So it's controlling the topic that we're reading in the namespace. And then it just returns that topic data. One really important point is all of these have an API trigger to expose them over MCP, and they also have a description of what the tool is. And this description is actually really important because it's prompt engineering for the LLM, and I'll show you what that looks like. So this is MCP Inspector. If you're doing anything MCP, you need this. This is the de facto test tool for MCP. It's going to communicate with HighByte over the MCP protocols. This is how we're going to test it before we expose it to an agent. So over here, I've got streamable HTTP. I'm connected to HighByte's MCP server. And when I call list tools, it's going to fail because it's a demo. Let's reconnect and try it again. We might have to relaunch the tool.
You know, this is how it goes. They say to pre-record these things, but then you miss all the fun of having something like this happen. It's all right.
So let's, it seems like my MCP inspector is hosed. Let's just jump to here and see if this works. What are the machines in my factory in their current state? Yeah, it's definitely MCP Inspector. So MCP Inspector is not a perfect tool. I am running like the latest version of it every time. So I'm just going to jump around and try to find the prompt. It runs out of a console. Here it is. So I'm going to kill it and reboot it, and then we'll get back. So we'll go look at this, but I'm using LibreChat as my agent. Okay, so we'll go look at MCP Inspector and what it's doing once that boots back up. But what this does is it goes out and calls the 2 MCP tools that I exposed. So the first one is browse. And what it's doing is it's pulling back, just as we saw in debug mode, all the topics that are in the namespace. And then it's actually going out and calling the read tool 5 times. Yeah, 5 times to read each topic. And then it's summarizing the data. So 2 things. I'm using LibreChat as the AI agent. I think the agentic platform you use to get started isn't that. There's a bunch of them. They're all kind of converging. You just want to choose something. Here comes MCP Inspector along for the ride. You want to use something that gets you started and can interact with MCP. The other important part is like, this is not, I'm doing this as a proof of concept, right? If my MQTT namespace has 10,000 topics and I return all 10,000 in this call, and then it goes out and calls this 10,000 times, that's poor tool design, right? Like that's going to cause a lot of issues in the context window of the LLM, and it's going to get confused. So great demo. You probably want to scope your tools to do some filtering, maybe more precise depending on how you deploy your agents to do this. So let's see if we can't get MCP Inspector. Aha, look at that. Okay, so we're going to call list tools, and we're back in action. What I wanted to show out in the list tools call is MCP Inspector does a really good job of showing you exactly what's happening over the LLM. So this is the request to list tools, and this is the response. And specifically what I want to show you, and this is really MCP protocol stuff, but it's important because this is what we're responding to in MCP. Now, this is a list of all the tools, and I only showed you right now the browse and the read, MQTT read, but we'll have some other tools we'll get into. But you'll see that, don't know what that is. You'll see that description field that we filled out in the pipeline is in here verbatim, right? So what this is prompt engineering. So think of this as this whole thing is getting copied into the context window of the LLM, and this is what it sees when it's trying to figure out what tools the MCP server exposes and how to call them. So this is prompt engineering. That's the first thing. The second thing is this tool list cannot be infinite, right? This is filling the context window. And actually, if you get around 100 tools, you'll actually flood the context window and the LLM starts to get confused. So being able to scope your tools and decide what tools go to what agent actually becomes really important when you go to optimize this stuff. Cool. So we lost a little time in MCP Inspector, but we'll gain it back. So we got real-time data. It's working, right? But the other piece we need is historical data. So what I've done in this demo is I've wired up all the UNS information is also going to Pi, and I'm storing that in a Pi archive. And now I want to expose the Pi data to the same agent so it can get historical. And similar to what I did in MQTT, I've got some really basic tools here. That the first one is browse. And if we look at this and run it through debug, it's going to go browse the Pi archive. So I'm not using Asset Framework. This is just raw archive data. And it's pulling back all the point names. And in here, because this is a test environment, there's a bunch of junk that I've posted from other demos that I don't want to feed back to the LLM. So what I've done is I've scrubbed that out, right? So I'm only feeding back the points that matter, that are in this demo to the LLM. I'm sure your Pi archive and data sources are perfect. Nudge, nudge, wink, wink. But I need to scrub that because I don't want it to get. We're an industry. We all know our data's a mess. But I need that ability to filter it. So I wanted to show that. And then the read raw history is just an ability to read multiple points. And let's explore that through MCP Inspector. So here I can run the browse. I'll get the points back, and then I can read the raw history. And this one's a little different than MQTT. What I've done is I have an array of points that I can pass. So I can say, give me the raw history for all these points. And then what I've exposed in the tool is a relative time. So I can say, give me the data from now till X minutes ago. I could use absolute time ranges in here. If you do, the LLM will use the dates from its last training window. So just know that that's an artifact, and you need to prompt engineer around that. But that's the reality of the world we're in today. So you run this, and it's just going to return the raw archive data for this point, and you can see this is kind of how it's representing it. But now we have an MCP tool based on that, so we can actually interact with that with the agent. So let me go in here, and I'm going to say, Can you give me the raw crusher data for the crush rate and the feed rate for the past 2 minutes and chart it? Nope. Chart it. Chart it. There we go.
We knew it was going to happen.
Yeah. Now here we're really throwing ourselves out to the LLM, because you can see it's making the right calls, right? It's going to browse and it's going to pull the data back. And now what it's going to do, it's going to build an inline HTML page. It actually looks like it might work, to display a graph. And this is where, like, I laugh, like every 10th iteration, you get a cat meme. So I don't know if this one's going to work for the demo. Success. So this is cool. And a lot of people are demoing this, right? This is an LLM just building a graph on top of the data. If I was doing this in production, I would go back and make sure that the LLM's actually charting this correctly, but it's a great demo, right? So yeah, now the last piece, if I'm not out of time, given my MCP delay, let's say we did this. Let's say we tuned an agent to work off real-time data from our UNS and historical data, and we've tuned a use case and it's working. So we know if we use this LLM and this agentic platform and we expose this tool set, right, that takes these parameters and returns the data in this format, we're good. We know it works pretty reliably. Then we go to the next factory. Guess what? They don't have Pi. They have timescale, which is a new connector we added. So they have a totally different data storage technology.
Mm-hmm.
So what do? This is the coolest part of the demo. So we definitely want to do this. So what I'm going to do is, instead of going through the Pi interface, what I do is I have a sub pipeline here, and we'll go look at it quick, is I'm going to wire into timescale. Now, obviously, timescale is Postgres based. It's going to store the data entirely differently than Pi in archives. But the important part is we need an API layer or abstraction so that the agent and the agent doesn't need to know the difference, right? It's going to make the same call. It's going to get the same resulting data structure, and it can continue on with its workflow. So what I'm doing here is I'm routing the calls now through timescale. And if I jump out, you'll see I have MCP tools that I've created for timescale. And if you run these, essentially they're going to return the same result that the Pi queries return. And the raw read's a little more complicated because I need to go format. I'm going to pull it from a different storage technology, but I need to format it the same way that I did when it was Pi data. So I need to be able to control that tool. But now that I've done that and saved it, I should be able to come back and say, everyone cross their fingers, do that again. And the data is going to be a little different because we're obviously querying a different interval, but I should get the same result, right? Because the data is structured the same. It's already done it once. It's in the context window. It's probably going to come up with the same result. We just have to wait for it to build out the HTML. There's a slight delay in the share. Aha, there we go. Cool. Right, so it's subtle. I went fast, but I totally changed my storage technology. And because I have this API tooling layer and HighByte enabled to implement the downstream part of that, I was able to switch it. Pretty cool. The last piece of the demo, just for that last question, in terms of alerting, what you can do, is not hit the mic. I just hate typing. There seems to be an error with the crusher. Can you send an alert to maintenance so they can work on it? It seems like the feed rate alert to main. So if you look at the demo, I have a tool that's like set alarm. What it's going to do is it's going to drive an alarm down through ignition, but it exposes a tool that just says, hey, set the alarm. And then I can go into the ignition platform and you'll see that message was updated. But I'm doing the request response here for this webinar, but obviously this could be an agent that I just give instructions and it sits here and tools on this. It's the same thing. I think the really important part is when you go to drive these things to production, you really have three variables. You have the LLM, you have the agentic platform, and really prompt engineering, and then you have the tooling. LLMs are all kind of converging, right? All kind of the same capabilities. Prompt engineering is a thing we all have to live with. The tooling actually becomes really important. So being able to spec out your tools and control becomes a really important variable in the performance of your agentic AI. And that's why building custom tools is really important. All right,
nicely done, Aron. No, it's great. Thank you. That was perfect. I'm actually, I'm going to launch a poll to everyone now. So we've talked a little bit about MCP. We have shown the new MCP server in HighByte Intelligence Hub, the latest release that was just announced July 1st. So now I'm going to ask attendees, where are you on your journey? Are you doing nothing? Maybe a little planning, hallucinating, experimenting, and hopefully seeing some success, or you're truly in production? I think as you could see in the timeline that Jeff shared earlier, the tech is moving fast. So trying to keep up with both the technology and then how that carries over into real deployment in highly regulated industries is interesting. Cool. Okay, so I think polling has slowed down a bit. Looks like planning is the majority at 42%. So you guys are in the right place here at this webcast. That's great. And then I'm really excited to see that more than a quarter of you are experimenting and seeing some success. So that's pretty cool. I'm going to minimize this. Great. And then let's go ahead and jump back into the next question, which is also on MCP. I know this is long, but this is a really good question from Santosh in India. And I think it gets more into the governance security aspects. So HighByte's MCP server lets AI agents treat parts of industrial data pipelines like tools they can call on. But what happens if someone tricks the AI into running something it shouldn't, like sneaking in a malicious prompt or chaining calls that reveal or corrupt data? In everyday terms, how does HighByte plan to lock down who can call which tools and make sure nothing fishy happens when pipelines get used together? So for this one, Jeff, you want to take this one?
This is an incredible question. So let's first level set on what the MCP server looks like in the context of Intelligence Hub. So for those who aren't familiar with Intelligence Hub, there's a construct called pipelines. And so when you saw Aron messing around with that earlier, all those different stages, right? Largely a pipeline typically involves bringing in some data into the pipeline and then doing processing and writing it out. That pipeline obviously can be exposed as a service, whether that's an API or exposed to the MCP server, right? Anytime that is able to be externally exposed for anything to call up, that runs through our internal sort of security model, right? So when those are exposed, so essentially pipelines become tools, as you saw that Aron just built. Within the Intelligence Hub, there's a configuration construct called tags. So that could be something like, hey, I want to control what models can be updated by which users and so forth. That same principle applies down to how access control is facilitated for external endpoints calling into the Intelligence Hub. So there's a couple of things, key pillars that I would kind of touch upon that's necessary, that I sort of feel that's important to facilitate like secure and safe agentic AI. And it comes down to a couple pillars. First thing is authentication, right? So can that MCP client or that agent be able to make even interface with it, right? So so that's going to be encrypted in transit. It needs to be able to have access. But once it has access, there's another question of, is it even authorized? Which pipelines does it have access to? So within the Intelligence Hub, you can effectively tag which pipeline. So suppose I created a tag called tag X, and that was maybe associated with a role that user X belonged to. Essentially, I could control what MCP clients, or that is what MCP hosts, have access to. Additionally, another thing to think about, and sometimes there's confusion sometimes with respect to large language models. They're not calling the APIs, the MCP server directly. That's done at the agent. And so one thing that I also think, unfortunately, this is kind of beyond the scope of our MCP server, but I think it's really important to longer term for people to think about is, when I design my agent, what guardrails am I going to put in place? What am I going to allow something to do and not do? What are the operating parameters with which this agent can go into? So beyond this, once that we know that an agent can securely connect, we know that it has access to things. We also need the ability to be able to observe what's happened, right? So we have tools where we could play back what was called, right? We could log things, right? But also, even more important, particularly for like regulated industries, is we also need the ability to be able to audit things, right? We need to be able to see, did someone modify a pipeline, or are they messing with security claims as an example, and maybe they're giving access to something that that shouldn't, right? So it really comes down to 4 pillars: being able to authenticate, being able to authorize, being able to observe, and being able to audit to make sure that that your journey with agentic AI is safe and low risk.
Perfect. Thanks, Jeff. Again, great question. Here's another. This one is from Ricardo in the United States. I'd like to understand the change from SSE to streamable HTTP for MCP. That's a lot of acronyms. I'm glad I got that out okay. Will HighByte have standard pipelines exposed to the MCP server templates? Aron, quick response on this one?
Yeah, MCP is changing fast. So SSE was deprecated. That's server sent events. It's still possible in the new streamable HTTP, but clients need to request it. Server sent events are really for long-lived requests. So if an agent requests something that takes minutes to return, it's a way to keep the socket open and then the server can respond. So technically that's more what it's for. So it's still there, but you don't see a lot of clients supporting the new SSE over streamable yet. We actually don't. Like, we'll return a failure code if our client requests it, but it won't block the client. They can do normal requests. Will HighByte have standard pipelines exposed to MCP server or templates? Kind of what you showed. Like, what we will do probably in the next version is for OPC, Ignition, common platforms, we'll expose out of the box pipelines that you can just opt into to do common stuff. But the really key point is, as you start to gain specificity in what the agents are doing, you really need to scope the tooling, right? So that's where the customization happens. Sometimes I think LLMs and agentic AI is like the greatest parlor trick in the history of humanity. I do think it's extremely useful, but you can show some amazing demos that just, 9 out of 10 times they'll succeed, and then the 10th time they'll fail. In industry, we can't really handle that. You need a way to handle that failure. And one way to do that is to scope and control tools is one of the main drivers. So I don't think we'll ever just have a switch that's like all pipelines become MCP tools. To security reasons that Jeff mentioned, you really want to scope that to certain, like, these agents have access to this tool set and they're producing this outcome, is kind of how we see the future of agentic AI in manufacturing.
Thanks, Aron. Thanks for keeping it real. Last question in this section on MCP before we move on to AI-assisted DataOps inside the Intelligence Hub is, we have no experience in MCP. How do you recommend to start? And this one came from Jerome in France. Aron, Jeff, I'll let you both give a very brief answer on this.
I guess I'll start. First of all, HighByte, obviously there's a 2-hour trial. You can download it. All of this tooling is essentially free. I'd say be focused on a particular use case or data set. This is not something that you're going to say, hey, give me all the data and start reasoning on it. The key takeaway that I would guess it's guidance going forward, I'd say, is APIs are not MCP tools, right? So APIs are general purpose things for resource extraction or interacting with them, whereas MCP tools are purpose built, right? So they're more human-like. They need textual descriptions to be able to interact with things. So basically, focus on not having too many tools and having high-quality tools is important.
Aron, anything you want to add to that?
Get MCP Inspector, download HighByte's 2-hour demo, just start tooling around with it, for lack of a better term. It's a very where I see people challenge is like, we need this huge AI strategy and we need to go all in and spend months in investigation. And it's really a skunk works. Like, you need to start to hook some stuff up and get a test environment and play with it. And I think relatively low barrier to entry, and we have knowledge bases and stuff to help you get started in that.
And we have customers doing it now, which is great. Thanks to Andrea at Idahoan, who lent his voice to the latest release of version 4.2. It's fun to watch customers start to experiment in the real world with these technologies and share their journey with us. So it's happening today. All right, we're going to move on to the next topic, which is AI-assisted DataOps. This is actually going to set up a demo too. And the question here, I summarized them in the bottom one, but essentially, how can I use an LLM to contextualize data in HighByte? Any tips? And then another question specifically came in from Ricardo in the US, who had some very good questions. I'd like to see an AI assistant creating instances of a model with a local LLM. So to answer these questions, I'm going to turn it back over to Aron.
Yeah, I'm seeing some great questions in the chat too. I'm tempted to answer them, but I know we got Ty and some other folks and Ryan. All right. Let me tire screen. There we go.
Aron, you
Click
just
on
stay
the share.
focused on demos,
I
okay?
know. I got like all these threads kicking off. So what I'm gonna quickly demo here is we talk about DataOps for AI. So data plane for AI agents, MCP tooling, everything I was showing before. There's also AI for DataOps. So how do we use AI to help contextualize data and build configuration? And when you think about MCP tools too, I saw one of the questions. You can think MCP tools for data. That's what I was showing before, right? You can think MCP tools for configuration. That's really product specific, right? Generating, and you'll see us go there too. And then also like MCP tools for like troubleshooting and data lineage stuff, and you'll see us go there. But this is specifically configuration and using AI for data ops. So what we've added in this release is instance creation is hard. When you have to go map a bunch of OPC UA tags to put some context around that, it's not fun. We do a bunch of stuff to try to make it easier, but that's an area that AI can very easily help you put some contextualization around data. So in this really quick demo, what I've got is I have one of the crusher machines. So
Hey,
actually
Aron, I don't want to let you get too far, but we're not seeing your screen right now, which you probably want to be sharing.
Yeah, that's I have to redo it. Okay. Let me know when it pops up. Aha. I think that's it, right?
Yeah.
Cool.
I mean, I was like trying to use my imagination, but I think it might be easier if we just see it.
I'm an engineer. I don't have that. My descriptions aren't that good. Not that creative. So this is an instance that I've manually generated, right? So this is another crusher on a different line. And what I've done is I've manually gone through and, this is the typical process of, and I'll just extend this. So I've got line 2, and then I've labeled it crusher. So that's a pretty good hint. But then the tag names are kind of weird, right? So these are the tag names that are coming from the OPC server. And I've manually dragged and dropped these because I know what these mean into their correct term. And when I read this, I get a nice instance. This is the manual process to create this. But if I've done this once and I know I have multiple of this asset in the server, why can't I just use AI to say, hey, go find the other ones for me, or at least make an attempt and do that? So here what I'm doing is I'm going into AI mode for instance creation. I'm basing it off the example that I had created, and I'm saying, go look at the rest of this address space I'm providing you, and then use an AI model. In this case, I have Bedrock and OpenAI to go look at that namespace, find other instances, other types of this asset in there, and manually map it for me. And this is what I would call, this is really interesting place for UX or where it's going. This is the AI loop. So think of it as like it's an automation slider. I can do it totally manual. I can do it totally autonomous with MCP tooling and agents, or somewhere in the middle. And I think currently with AI LLMs, somewhere in the middle is really important because you need a human in the loop to validate the output. So how do I optimize my UX such that I can put that slider in the middle, have the AI go do something, and then I as the human can efficiently review it and then say yes or no or make tweaks? And it looks like it did a decent job here. So it found the other lines, and then what this UI is showing you is these are the instances that were created, and this is where it mapped the data points. And then I can actually test read these and see that it maps. So what it's done is it's removed the manual mapping step for me, and it's gone and discovered that. And then in this UI, I could go back and give it additional instructions if I didn't like the output. In this case, it looks like it did all right. So I'm going to import these. And then you can imagine now that I've got the mapping created, I can go, let's just put line 3 in, and then I can create I can just drag that instance in, and I'll just recall a crusher. And this is our namespace feature, but it's now, if I go back up, it's part of the namespace. So it should start, line 3 should start to appear. And then because I've done all that, if I go out to the UNS client, given this project, it should just auto pick that up. And we should be able to see that. Getting a little, there we go. So you see the crushers. So
Nice.
all those MCP tools I built will pick that up and they automatically work. So it's just one example. And I know you're probably watching that and go, well, why do I need to add it to the namespace? And why can't you automate that? And the answer is that's where we're going, right? Kind of this automation of, I want AI to assist me in contextualizing the data, putting it in my namespace, and even building pipelines and other stuff. So we're experimenting with all that. But I think industry-wide, that kind of automation lever is an interesting thing to think about, and how that winds up in UX design over time. And that's our first attempt to it. We'll obviously iterate and improve. But
nice. Thanks, Aron. That's great. Let me jump to one question So Aron, you have 30 seconds to answer this one. Can you estimate the percentage of your customers you believe are positioned to 1, use, and 2, get value from industrial AI? And this came from Joseph in the US. Aron, how would you answer that?
I'm going to take the sales answer. And no, I think all of our customers are, right? Because our customers they realize the need for industrial data ops and data contextualization. So they have that. They're either on a UNS journey or overall data contextualization journey and realize the importance of that. And now that we have MCP capabilities like we've shown, like they're ready. I would say that a lot of it is still proof of concept, and the folks that are farther along, when I'm talking about like tailoring tool design and trying to optimize the agents, they're running into that really quickly, and that's why we've designed custom tools and everything we've been talking about. But I think selfishly, all of our customers are ready. Like where you get in a challenge is, okay, like the equipment isn't even connected, and we don't even have an OPC server, we don't have HMI or what different parts of that journey. Like you do need to be industry 3.0, I would say, in order to make the jump into this. And if you're trying to use AI to short circuit that, you're going to be frustrated.
Yep. Foundation becomes more important than ever.
Yeah.
Let's ask our attendees, now that we've shown you DataOps for AI, so the example of the MCP server that Aron shared that's enabling agentic, and then also AI for DataOps that's making it easier, faster, more scalable to use HighByte Intelligence Hub to perform data contextualization, set up instances. Which one do you think will make a more significant impact on your data management? So far, it's a tight race. Just curious to learn. I mean, it was an interesting release for us because we made significant improvements on both ends. So just curious to see how that's resonating with this audience. Looks like DataOps for AI is starting to pull ahead. Aron, any surprises there? Is that what you were expecting to see?
It makes sense. Yeah, I think the more interesting part, like I'm all about the operator assistance use cases with AI. I think like being able to verbally communicate with my machines on the factory floor and get feedback to help me troubleshoot is like, it's a very creative task. And I think AI is really well stationed to do that. I will say, when you talk about data ops for AI, in the tooling piece is so important. Like if I went and used Pi's MCP server, they don't have one. Don't go Google it. They might add it, right? It would have been really challenging to go to that next factory with timescale and implement the same agent. Like I would have had a lot of work. So that API layer concept is really important. Whether you use HighByte or not, my sales skills are coming out. Like you really need to think about that because it'd be really important to scale.
You're making Steve's day. Thanks, Aron.
Yeah.
All right, I'm going to minimize that poll, but keep it open for a little bit in case anyone didn't have the chance to respond. We're going to switch gears now. We just have 2 more questions left, which is good because we're approaching time. The second to last question is, what does it mean when you say apply DevOps to DataOps? It sounds like kind of 2 worlds converging. And so for this question, Jeff, I think you'd like to answer this briefly, and then Aron, maybe you have a brief demo that you can squeeze in here.
Fantastic. So we have customers now with well north of 100 sites and so forth. So given the licensing model and so forth, it's not uncommon to have many hubs per site. So conceivably, one could have hundreds of hubs running around their enterprise. There is the whole central config thing. For those who aren't familiar, that's largely a functionality to remote into hubs and share configuration. But once you kind of get at a certain scale, there's a broader problem space to consider, right? There's versioning the software, right? So making sure that you're upgrading to 4.2, wink, wink. But you also have to think about configuration, right? It's very common in, like, let's say cloud architectures where maybe you're publishing, let's say, to S3 or Snowflake, as an example, in the upper half of your Intelligence Hub configuration might be pretty similar across all of your sites, right? But however, given the chaos of all your industrial automation and maybe the mergers of acquisitions that you've been through the past decade or so forth. The bottom half of your Intelligence Hub configuration can be heavily localized, right? One site has Aviva, the next has Schneider, the next has Siemens, and so forth, right? So there becomes quickly a manageable management issue to consider. The first area that we think about for is version control, right? So one, how do I deploy Intelligence Hub, the latest version, but also how do I keep that configuration in sync? How can I make sure that I'm publishing to the correct, let's say, tables in Snowflake, but also maybe addressing all my sites that have Siemens and all my sites that have Rockwell, as an example, right? So the ability to be able to do sophisticated version control in backup is functional that we added in this release. The next scenario is, now that I have all these deployed, how do I know that they're running? How do I know that the underlying infrastructure is healthy? When we think about a use case to deploy a use case with the Intelligence Hub, we often have to think about end-to-end, what is Intelligence Hub interacting with? A lot of times to accomplish a use case, you might be modifying a network, modifying a database, modifying an application, and so forth. So a lot of times you're doing configuration management beyond just Intelligence Hub configuration. And so we need to make sure that that's running healthy. And so in this release, we added support for OpenTelemetry, which is basically an observability framework that provides plug and play capabilities to interact with it. We've long had the capability to read log files that expose metrics of the health of the hub, but we wanted to provide more of a turnkey approach. So if you're using Splunk or Dynatrace or Datadog or AWS CloudWatch or Azure Monitor, right? This provides a more turnkey approach to observability that's going to surface that capability. So together, we sort of view this as providing DevOps for DataOps.
Aron, would you like to add to that?
Yeah, maybe just show a demo of how to deploy. This will be my last one. If I can share my screen. Step 1, share screen. Step 2, turn mute off on your mic. Like it's the basics. So what I'll show quick here is we have a Git integration now in 4.2, and what that means is I can take that project that I started out by showing you that's up on that sample repo, and basically the quick way that this works is you create what we call a deployment JSON file, and what this is, if I can get it to open, is this is what you feed the hub on startup to say, hey, where are you going to go get your config? And there's an example of this in the repo, so that we try to make it as easy to test this out. But essentially, this is saying, hey, I'm going to point you at that repo, that public repo that I showed you at the start. And then in there's a fragment, so you can pull like pieces of it or the whole thing that is that config file. And this exists on disk. And then what I'll show you real quick is I'm using Docker locally. So what I'm going to do, I've already brought in the 4.2 Docker image, and this run command's a little gnarly because I'm on Windows and I need absolute pass. But what this is doing is saying, hey, take that file I just showed you, mount it into the Docker container. That's what that's doing. And then there's an environment variable that says, hey, start up with this deployment file. And when I hit that, what this is going to do is go run HighByte. We're going to go pull from that repo. We're going to load in the configuration, and then we're going to run. So once this, my machine's running a little slow, but once this spins up, we'll basically have a replica of the demo environment that I was showing you running under a different container just called HighByte Get Example. And I've modified the ports here by 1, so it'll be up and running. Actually, while that's going, the other piece I'll show you real quick, if I can find my footing, is we also have OTel now. So OTel is it's called OpenTelemetry. It's a standard for getting runtime statistics out of products. So if you're in IT, you're probably really familiar with this. If you're in OT, it's probably fairly new. But essentially, if you have hundreds of hubs out and running, you want those to be able to report back on their statistics. So this is an example of the environment that I've been demoing the whole time. I have that connected to OTel, and then I'm using an image in Docker that kind of encapsulates Grafana and everything else to show that. But this is like the, CPU and error rate. So you can actually, there's some built-in dashboards where I can look at like the JVM we're running in and get like heap utilization and CPU utilization, which is net new. Like we don't offer that out of HighByte by default. So this is a pretty cool capability. And then also in here, we'll publish up log information. So you can see logs over the past few minutes, and then the metrics. And really, you would use this to build your own custom dashboards. What I'm showing you is just the default. But as a real quick example, you could look at the connection name equal to UNS is the one that I was simulating data out of. And this would show you things like the read and write counts. And I think there's a write count in here, write timing. So this shows you the time for each write that we were issuing out. So you can see that increased a little bit. I mean, we're talking milliseconds. That's just probably my PC. But this would be a way to monitor one or many HighBytes at scale, kind of out of the box. And all you really do to enable it is you just launch the product with an OTel command. And now it ties into this infrastructure. So another example of just a DevOps-y like tool that we now run into. And let's just see. So there's some errors because of connection passwords and stuff. But if I launch that, so now if we go to this port, oops, it should reach 4226. I think my PC needs a reboot after all these demos. But this should launch the other version of HighByte that I just launched from the configuration, from that Git repo. And you can see it's unlicensed. I haven't applied a license here. And there's some errors, but essentially this is all the same configuration that I was showing you in the demo. So assuming pipelines loads and my PC gets through this, you'll see the same set of pipelines and everything else we were doing. So people were already doing this manually, but this is just a way to provide out of the box solutions to help them.
Perfect. Thank you. All right, last question. I know we're coming up on the hour and we promised we'd let everyone go at 55 minutes, but if everyone can just stay on for a minute, it'll let us answer this last question, which is just forward looking. And Aron, I'm going to come back to you from this. And this question came in from Renaud in the Netherlands. How does HighByte envision the role of agentic AI evolving within industrial environments over the next 3 to 5 years, especially in terms of autonomous decision-making and integration with existing systems via MCP? Thoughts on that, Aron, before we wrap up?
Yeah, I mean, the things today are the context windows are a challenge, and then determinism of LLMs, and those two are related, right? So I think if LLMs become like an order of magnitude more deterministic, they can take on larger tasks reliably. I think today what we see with the current technology is you're going to see very specialized agents on like certain machines doing maintenance, for example, on the crusher. So in my example, I might have agents deployed for each machine type that are tuned to that machine, have tools to pull data off that machine. And then I'm using something like A2A, agent-to-agent protocol to communicate between them. So you're going to see them distribute and scale down agents. I think that's definitely the future of agentic AI. I think today there's a lot of focus on autonomy. And because of the lack of determinism, we're not, and this is coming from the LLM, that's the limitation. We're not there yet. So I'd be cautious of anyone being like, oh, we're just going to totally replace humans and do these autonomous workflows reliably, because there's lots of information, articles, blog posts coming out that like, as you increase the number of steps the agent needs to take, it like the reliability degrades almost exponentially because of the failure rate. But I do think there's so much opportunity in the whole human to machine interfacing, operator assistance on the floor, tasks that are not necessarily deterministic, but if you put a human in the loop, AI can make you so much more efficient. And I think in the next year or so, again, if we get to AGI, like all bets are off, like that, the world changes and like, who knows? So I'm not even going to consider that right now. But I do think that creative tasks, operator assistance, there's tons of opportunity there to drive efficiency. And that's what I'm most excited about currently.
Awesome. First of all, I want to thank everyone for attending today and for lending their questions and their thoughts. You guys certainly kept Ryan and Ty pretty busy. And then, of course, thank you, Jeff and Aron, for all the work that goes into these. They're fun, but I know they're also a lot of work as you think about what you want to share. So the last thing that I'll shamelessly plug is if you enjoyed this webcast and you'd like to meet us in person, you can meet us at DataOps Days. So HighByte is hosting our first in-person events this year for our users, customers, partners. It'll be this fall in Pittsburgh, Houston, and Boston. So if you find yourself in the United States, we've co-located with other industry events that are happening, including Operations Calling in Boston. So if you are in the area, come see us, and it'll be a day of pretty awesome programming. So that's it. That's my shameless plug. Thank you all so much for coming. And again, this webinar was recorded. We'll get it out to you in the next 24 hours. If you need the slides, you can let me know that too. We'll probably just go ahead and package those up in the email. And thanks again for joining us today. We'll see you soon.
Cheers.